Hi guys, welcome to Mature Chemistry. So in today's video, I will be converting some vitamin B3, also known as niacin or nicotinic acid, into a stinky liquid called pyridine. This is actually the second video in a short series about making some beautiful fluorescent copper complexes, and if you don't want to miss out on anything, I strongly recommend you to watch the first one. Anyway, pyridine is structurally very similar to benzene, except it has a single carbon atom replaced by a nitrogen one. This makes it much more reactive and interesting, and it has a ton of applications in many fields of science. I, however, won't be using it to change the world and develop new useful molecules, and instead, as chemists do, I want to satisfy my need for some pretty colors, so I will use it to make some colorful compounds in the next video. To make it from vitamin B3, I just need to take a carbon dioxide molecule out of it in a reaction known as catalytic decarboxylation. I know that to the non-chemists, this name might sound pretty terrifying, but essentially what it means is that I just need to strip a carbon dioxide molecule from something with the help of a catalyst. In a lot of decarboxylation reactions, such as in making phenol from salicylic acid, the catalyst is not required, but it just so happens that vitamin B3 is one of these pesky molecules that require something fancy to give up their carbon dioxide. Fortunately for me, the catalyst required is either copper chromate, which I won't make because it is essentially just powdered cancer, or basic copper carbonate, which I already made in a previous video and will use in this one. So for the decarboxylation, I firstly have to weigh out my ingredients, and the first one is 100 grams of vitamin B3, which of course looks just like a white powder and was generously provided to me by a great chemistry supply shop, BM Chemistry. BM Chemistry sells a lot of difficult to get chemicals of high quality, along with laboratory equipment and lots of other things, so I recommend you to check out their page, to which I provided a link in the description. So thanks again to BM Chemistry for providing me with lots of chemicals, and now, after weighing out the vitamin B3 and pretending that I didn't spill anything, I have to weigh out 24 grams of basic copper carbonate. For some reason, I chose to use a watch glass for this, which was a terrible mistake, and I of course spilled even more of the powder and tried very hard to pretend that nothing happened. After all, this is a mature chemistry. When the ingredients were weighed out, I now had to mix them very thoroughly because otherwise the reaction wouldn't work, and because of that I couldn't use my trusty mortar and pestle, and instead I had to resort to a more powerful method. In other words, it was time to use my old coffee grinder. I bet that most amateur chemists have this kind of a coffee grinder somewhere in the lab. I am no exception, and this is actually my third grinder because these cheap Chinese grinders break very often, but are incredibly powerful. My one is pretty old and worn out. It is also missing the bottom plastic part and likes to turn into a smoke machine when it's running, but I cleaned and fixed it so many times that now I am emotionally attached to it and I will use it to mix my ingredients. I poured both powders into the grinder, screwed on the lid, and reinforced it with some tape to prevent it from leaking the powder everywhere. I then plugged the grinder in and turned it on. It didn't seem to have any issues at first, but after a few seconds of grinding, it started screaming in pain, so I turned it off, and of course, some smoke started coming out of it. After letting it cool down, I got it above my trash can to open, because I know that a lot of the powder is going to escape. The opening went fairly tame. I lost only a tiny bit of the powder, but when I wanted to transfer it into a beaker, this happened. I mean, this is the third time in a single video, and I officially ran out of excuses. Anyway, after telling you a ton of my grinder's personal information, I now need to assemble a distillation apparatus to make the pyridine. I actually already did this reaction before to make sure that everything is working, and one of the joints got stuck so hard that it was nearly impossible to separate, so for this distillation I wanted to grease the joints, which I should have done a long time ago, but I guess it's better to do that late than never. I of course don't have a tube of professional joint grease, because I am too broke to afford it, but I recently found some old bike chain lubricant, and I know that every chemist watching this video is probably screaming bad words at me right now, but this stuff is much better than nothing, and it doesn't seem to interfere with anything, so I just greased all of the joints with it and called it a day. I also filled the boiling flask with the reaction mix without spilling anything for once, started the water flow and turned on the heating. The temperature that this reaction works best in is about 250 degrees Celsius, but it's important to monitor it, because if it is too high, the vitamin B3 will start to sublime and escape, contaminating the product, and when the temperature is too low, the rate of distillation will be trash. Even when the temperature is okay, the distillation rate is still trash, and the distillation is so incredibly slow that it ended up taking me about 18 hours. I covered a part of the apparatus with aluminum foil, and after about an hour of heating, I started to collect some disgustingly yellow distillate, which should be the pyridine mixed with a lot of residual water and other impurities. This whole distillation, apart from taking ages and producing a yellow product, also makes your lab smell like a disgusting mix of fish and anchovies, and this smell is actually that of pyridine. Pyridine is also pretty toxic, so when the distillation was running, I had to turn on my fume hood and wear a respirator at all times. Somewhere in the middle of the distillation, the distillate turned crystal clear instead of yellow, which was a good sign. After 18 hours of distillation, I couldn't see much more distillate collecting in the receiving flask, so I turned off the heating and waited for everything to cool down. I also poured all of the terrifyingly yellow distillate into a smaller flask, sealed it with a stopper, and put it aside for now. I wanted to take a look at the boiling flask after the distillation, and when it was cold enough to hold, I got it out of the heating mantle, and it looked like somebody detonated a nuclear bomb inside it. There was still some unreacted starting material and crystals of the vitamin B3 that sublimed away in the flask. I could recover them, but after disfilling this thing for 18 hours straight, I just decided to throw all of the unreacted stuff out and clean the flasks, which turned out to be a big pain, but eventually, using a ton of hydrochloric acid and sodium hydroxide, I managed to remove all of this crap. Anyway, I now have to purify my pyridine, since it is contaminated with a ton of water, unreacted vitamin B3, and some yellow crap that I have to get rid of. To do that, I got the flask with my distillate, dropped in a stir bar, turned on the stirring, and added 3 grams of sodium hydroxide. The sodium hydroxide will initially clean the pyridine of impurities by holding onto some of the water and precipitating the residual vitamin B3 by converting it into its sodium salt, which is insoluble in pyridine. After stirring this mixture for about 20 minutes, it progressively got whiter and whiter, which was a good sign of progress, and when I felt that it was ready, I took it off the stirring and proceeded to filter this mixture using vacuum filtration. The filtration removed a good portion of the solid stuff that precipitated, but the pyridine was still very yellow, which is one thing to worry about, and it also probably has a ton of water still present that I need to somehow get rid of. If I just wanted to follow a procedure, now it would be time to distill the pyridine, but me being me, I wanted to try one last thing that might help to purify the pyridine, which is the addition of some potassium hydroxide. I didn't see anyone use it before for purifying pyridine, but I wanted to see if it would improve things, so I just dumped a random amount of it into the impure pyridine. It immediately made it turn orange, which was pretty weird, but according to the creator of the bias against yellow chemicals, orange is okay, so I guess that everything is going well. Just like the last time, the solution also became very cloudy, but other than that, there was not much else happening, so I just vacuum filtered it. It didn't do anything, but I didn't care much and just proceeded to the next step, which is of course the second distillation. It should remove all of the impurities, and to make sure that it does, I added 6 additional grams of sodium hydroxide into the pyridine flask for good measure and put it in my heating mantle along with this weird corner piece that just looked like it would break at any moment. I also greased all of the joints again to prevent them from being stuck, turned on the flow of water along with the stirring, and started to heat the boiling flask. I covered it with tons of aluminum foil for better insulation, and after a few good minutes, I started to see some vapors climbing up the apparatus. As my receiving flask, I used a big vial in which I will store the pyridine in. I also loaded it with some activated molecular sieves to make the pyridine extra dry. The temperature of this distillation has to be kept at around 120 degrees Celsius, since pyridine's boiling point is 115 degrees Celsius. That also means that some water may come over, but all of the hydroxides present should hold onto it and prevent it from being a problem. After an hour of heating, I started to collect some crystal clear drops of liquid that hopefully should consist of pretty pure pyridine. This distillation, like almost every other one, was incredibly slow, but after 5 hours, I managed to collect a pretty nice amount of the distillate. By pretty nice, I mean acceptable, and in theory, I should have gotten almost the full vial, but I screwed something up and got only a whopping 10 grams of pure pyridine, which is an insanely low yield. To improve it, next time I should probably leave the decarboxylation running for even more time and use the forbidden cancer powder, aka the copper chromite catalyst. Anyway, to store my tiny amount of pyridine for a long time, I used some Teflon tape to enhance the seal and prevent it from evaporating, and before I put it in the freezer, I wanted to test its smell.
Oh god.
It smells very bad. It is hard to say exactly what it smells like, but to me, it smells like some kind of a weird mix of rotten fish, anchovies and garbage. It is pretty toxic though, and I don't recommend anyone smelling it. I did it only for research purposes. As I already said, I plan to use the pyridine to make some beautiful fluorescent copper complexes in the next video, and in the future, I may make some pyridine from it, but for that, I will need much more pyridine. Anyway guys, thank you very much for watching, like and subscribe if you enjoyed the video, and again big thanks go to BM Chemistry for providing reagents for my videos. I would also like to thank my patrons, especially the $5+ ones, who are R2D2, Riley Reflogo, Joseph Kudi and MI, for supporting my channel. If you would also want to support my work, you can consider becoming a Patreon, and see you guys in the next video.